This is a syringe clamp in Fusion 360. And since creating the part, I've actually been able to go in and get a few different syringes to measure them. And our largest syringe that we might need to clamp is 24 millimeters in diameter. So we'll want to change this clamp up to have an inside diameter of 24 millimeters. Now, thankfully, when we designed the syringe in the syringe clamp in the previous tutorial, we designed it parametrically, so we can come down here and we go back to sketch 1 in our design. So I came along the timeline at the bottom right here. These are all the different steps that I did while creating it. I went back to my very first step where I defined the critical diameters. And if I take that up to 24 millimeters, that makes that quite large. And since that's up to 24 millimeters in diameter right now, we probably also want to extend the mounting points out to, let's take it out to at least 25 on each side. And that'll give us a 50 millimeter wide bracket. And we can finish that sketch right there. And there we are with our new dimensions all put together and ready to go. So this will actually fit really nicely onto a 30 milliliter syringe. And we've got a few other sizes that I'll share with you in the comments or in the details section. But now what we want to do is we want to 3D print that. And in order to 3D print it, we need to get an STL file. So what we're going to do is we're going to come over here and under Tools. So click on your Tools, and under Tools, you want to click on Make, and then it asks you for the selection. You want to make this part. It goes through, it meshes that part for you. You can leave it at a high resolution, and we're just going to click on OK. And it will ask you, where do you want to put that model? And I'll put it in my 3D printed models folder, and I'll give it a unique name, JB Syringe Clamp 30 milliliters. Okay, so now I've exported this file as an STL file, and I can use a slicer program like Cura to slice it and get it ready for printing on a 3D printer. So now that you've got your STL downloaded, it's time to switch to your slicing software. And the slicing software I'm going to demonstrate is Cura. Cura is developed by Ultimaker for use with their Ultimaker machines, but it's also available to create G-code, sliced code for creating files on just about any machine. There's many other slicers out there, and arguing which slicer is the best is kind of like arguing whether Windows or Macintosh is best. There's obviously one right answer, but people don't like you to tell them. What? Edit, we should edit that. Anyway, in the software, come to software, and what you want to do is you want to, under software, you just want to go ahead and download version 4.5 or whatever the latest version is, and it should be available for Mac or PC, and you should be able to go ahead and download that for free. It's even available for Linux. There we go. So while that file is downloading, just hang on here a second. There's their thank you file, and you can just run it from the download folder. And if you've got an older version of Cura installed, it'll update to the new one. If you've got a brand fresh installation, Cura will just go ahead and install. And we'll close it there, and it will walk you through your setup. Read every word of the license agreement. I've read it 3 or 4 times. I've memorized it all, and I'm perfectly okay with it. And we'll go ahead and we'll put that into the default folders, and it's going to create some shortcuts for us, and it can also install some drivers. So this is basically how you get Cura up and running on your system. And if I remember what I'm doing, I'm going to hit high speed when I edit this, because that'll make my computer look really, really fast.
Even faster. Let's go back and edit this. Make it go really fast. There we go.
It's finished, and let's run Cura. And allow it access to your network. It's just looking around to see if there's any printers actually attached to your machine. It's not that big a deal. It's also going to check for updates. And here we go. Now yours probably comes up showing a picture of a Ultimaker. And that's because I've had this set up before, and I've already got it set up for the monoprice minis that we'll be using. So what you're going to need to do is you need to come into Settings, and under Printer, you want to be able to set your files up from Monoprice Select Mini V2, which is what we're going to be using at BCIT. Yes, we have the Ultimaker 3. Yes, we have the Ultimaker 5. But for this part, we can make it on the Mini. So we're going to add a printer, and we're going to add a non-networked printer, and it won't be an Ultimaker printer. You'll just scroll down here, and somewhere down here, you'll find Monoprice. And we've got the Monoprice Select Mini V2 with the E3D, and just go ahead and add that to your list of printers. Now when you do that, it pops up with a number of configurations that are already known that work well when printing from the Monoprice Mini. So it knows some things about the machine. It knows the size of the bed, 120 millimeters by 120 millimeters, and the height that the gantry can lift up to while you're printing. It knows that we've got a rectangular build plate. Some have a circular build plate if that's how the machine is set up. The origin is not at the center. We do have a heated bed. The G-code flavor, there's a couple of different ways that different firmwares that you can put onto your system. They interpret G-code slightly differently. This one's known as Marlin, and that is correct for ours. The Printhead Settings, just a number of figures again describing the machine, and we've only got one extruder. You can find out more about that extruder by clicking on it right here. The nozzle size is 0.4 millimeters in diameter, so when we print, the finest detail that we can possibly hope to get is going to be 0.4 millimeters in diameter. And the input material that we're feeding into there is 1.75 millimeters in diameter. And that's really important because that tells it how much input material, how much filament it needs to feed into the machine to extrude a certain amount of plastic out of the nozzle. The printer also has some G-code to start the file and to end the file. So this gets automatically appended to the beginning and the end of every set of G-code that we create. And if you've done any work with G-code before, you can follow that through and see that this is sort of a superset of the commands used on CNC machines, because of course they're not worrying about things like heating or extruding filament. All right, so we just went with the default settings, but let's click on Next. And there is our Monoprice Mini. I can zoom in and out by scrolling with the mouse button and rolling the mouse button right there. And what we're going to do is we're going to open up that file that we just saved. So File, we're going to open a file, and I'm going to pull that in from my 3D printer models, and there we go. I saved it as JB syringe clamp 30 milliliter. And that looks amazingly like the part that we just created. Now, in its current orientation, this would be an absolutely silly way to make this part. First of all, we have very little space for bed adhesion. So remember that 3D printing is a continuous process of building up one layer on top of the other. Well, you want your first layer to stick to the bed nicely and have it hold down well. And there's not very much surface area to allow us to have that hold right there. The other thing that happens is we come up right out here, there's nothing underneath this part right here, this part right here, or this part right here to support it. So that means when we go ahead and print and come up around here, we might be able to get out past this curve a little bit. But as soon as we start to get out to here, we're going to have material flopping all over the place and falling to the ground, and it's just going to be miserable. So one of the first things you need to get figured out when you're 3D printing is what's the best orientation for your project. So click on the project, you'll see it gets highlighted over here, and then you can rotate your model and just rotate it to 90 degrees and it'll sit flush on the ground. Okay, so now that model is sitting flush on the ground in there and looks reasonably comfortable on there. So now we've got more surface area for bed adhesion and much less in the way of support material is going to be needed. In fact, there's only a few places on here that look somewhat unsupported, and you can see that they're showing up in red. Okay, so if you see those red lines right there, that is Cura telling you, hey, I'm going to have some problem making these without a little bit of support. And right up here is not a big deal. I'm not too worried about that because while it looks like it needs support, what actually exists in there is that there's going to be some bridging going on because since we're coming up layer by layer by layer, we're going to have material right here and material right here. So we can have a bridge come right across there. And so that's not going to be entirely unsupported. Down at the inside the circle, we can actually clean that out after the print. So if we do have any problems with anything dropping from down inside there, we shouldn't have to worry about that too much. And then down right in here, you can see this part curves up right in here. And so as we go up layer by layer, we may get a little bit of loss of resolution right in here. But that's a small enough loss of resolution that I'm not going to worry about it too very much. So this is a nice simple part in a really good orientation. And what we're going to do is we're going to take a look and let's just go ahead and slice it right now, just with the default settings. We're going to come back and do some more advanced settings in just a moment. And let's take a preview of it. It says that's going to take about 40 minutes to print. And after it's sliced, you should get a view that looks something like this. And over on this side, you've got a bar that you can drag down and you can look at it one layer at a time. Now you'll notice the very first layer is a little bit special. It's not actually anything that we made with that part. And this is controlled by the bed adhesion settings. So we're going to take a look at that and play around with our bed adhesion settings to get something that should work really good for our part. And then after that, you'll see that there's a few layers of very solid material. Okay, you can see right in here that there's no gaps in that material at all. It's quite solid in here. And let's actually change this. If you come up to your color scheme and we can change this a little bit. Let's say take a look at the different line types that we have on here. So this will tell you a little bit more about what's going on. The blue material is all helpers. So that was our bed adhesion, that was helping us. And then we've got the shell in red, and that's just the outside line right there. That's going to be what's exposed to the outside world. So if we go back down to layer 1 right here, you can see that we've been growing that outwards a little bit. And then as we come up a little bit higher, we start to see that we've got this material right in here, coming in here, and this is our infill material. And the infill material comes in with a pattern, and it just provides some rigidity and structure on the inside of the part. So as we start to climb further and further upwards, we come to the top of the top of that mount bracket right there. Oh, that's just at the middle. I was thinking it was a bit low. And you can see the hole starting to form right in there. And then as we come up around there, the hole comes right to there, and then all of a sudden it bridges right across there. And that was one of the reasons I wasn't particularly worried about putting any support material in on that hole. And then we come up to the top, and just before we get to the very top, it starts filling in the gaps. So we get a couple of layers of nice solid material to brace the outside. Now, that's really simple to do. That print is ready to go, and it would probably print just fine and come out working a-okay. But let's take a look at some of the other things that we can change on there if we needed to optimize things a bit more. So right now, we are in the simple view. So come back to your prepare. And what we want to do is we want to come in here and we want to start changing some of these settings. So click on the arrow right there, and now you've got access to all of the settings in Cura. And this is where a lot of very powerful tools reside. Now, just as powerful tools can help you do excellent things, powerful tools can also help mess you up from doing other things. So let's take a quick look at what some of the settings are. Now, your layer height right in here controls the thickness of each one of those layers. And you can see that we're set at 0.1313, which for the Monoprice Mini is a fairly fine but nice layer height. You can change that up if you want. You'll get a little bit less resolution in your print, but whereas it took 40 minutes for it to slice before, if we go up to 0.18 and we click on the slice button, you'll see we're now down to 29 minutes. And that's because each time the 3D printer head moves over top of a spot, it's going to be extruding 0.18 millimeters of material instead of 0.13. The shell can also change our settings on here. And so the shell, when we were looking at our preview, you could see that we were talking about the wall thickness. And so let's come back to a preview view right here. And here you can see the wall thickness. If I zoom in right over here, let's come down a little bit. So we've got some infill material right there. You can see our wall thickness consists of 3 layers of solid continuous material. And you can see that our wall line count is equal to 3. We can bump that up if we want. If you need a thicker wall to make it a little bit sturdier, go ahead and slice that. And you'll see that now we've got the outer and then 1, 2, 3 behind that. And so we've got an extra layer of material on there. Usually that'll take a little bit longer to print and take a bit more material, but this is a small enough part that didn't really show up. And where we've got places where we've got 2 outside walls and not enough space to get 4 walls on the inside, well, we have an outside, and 2 insides there. If that was narrower, we'd just have 2 outsides. The top and bottom line thickness allow you to control how many layers you get at the top and the bottom. So as our preview comes up close to the top, you can see here we're at layer 55 is the top, 54, 53, 52. So those layers multiplied by the height tell you how thick the top and the bottom are. So again, if you need more strength in the shell of your part, you can increase those dimensions. Most of the stuff we're doing doesn't need that. You can also express the top thickness in terms of layers. Okay. So when you're done looking at a set of options, you can click the little tab right there and it just pops back up there. Infill does make a difference, and there's some interesting infill options. So right now we're set at 22% infill, which means that the space inside here is going to be 78% empty. Well, if we wanted to fill it in a bit more because we felt it needed to be a little bit stronger, and usually 22% is plenty, but if we wanted it to be filled in a little bit more densely, we could go up to 44% infill. We could slice it again. And now you can see that we have a lot more density right in there. The lines are packed much closer together. There we go. Just had to get the rendering right back the way it was. So we've also got different patterns that you can go with. Some of them create themselves in a 3D pattern, and you only see them after you've sliced them to see what's going to happen with that 3D pattern. There we go, off the top. The X's come together, the X's come apart. I don't think there's a big deal to be gained for most of the printing that we do. Just leave it set to grid, but it's nice to know that it's there, and that in the event that you do need to do something special on the inside of your project, that'll work well for you. For the material, we're working with PLA, polylactic acid, a biodegradable plastic made from corn, I believe. And so I've played around with it on the Monoprice Mini. It sets a default temperature of 200. I like to set mine up to 210. I find it just makes the plastic softer. It flows a little bit more easily out of the nozzle. And it's really challenging for the Monoprice Minis to get their build plate all the way up to 60 degrees. They will do it, but you'll be waiting longer for your print to start. So sometimes I'll set it down to 45 or 50 degrees. And really, you just don't need it that hot. Your print speed and your travel speed. Print is the speed that the printhead moves at 50 millimeters per second. And travel speed is the speed that the printhead moves at when it's not printing. So one print speed is when you're printing, and travel speed when you're not printing. So those are two numbers that I tend to leave alone. You can slightly improve your print quality by slowing the nozzle down a little bit, but at the cost of extending the duration of your print. You've also got travel, and again, that's another set of features that we can just ignore. And print cooling, just leave it set to the default settings, because we're going to take a look at support material. And support material is a big thing. Like I say, our drawing doesn't need a lot of support material, but let's turn it on and let's see what happens if we ask for support everywhere that our overhang is greater than 50 degrees. And you can see that cost us a couple of minutes of printing. And let's take a look right in here. And down at the front right here, you can see that it's generated this blue material right here, representing that as helper material. And it's come all the way through that hole. Now, the whole idea behind support material is that support material is made with just enough of a gap that after your print is all done, you can break it away, but until your print is all done, it intersects just right down here and prevents anything from drooping down too low. So support material is a really useful tool, but does run into problems sometimes because it ends up clogging holes and becomes just one more thing that you need to take off in your finishing process. If you can get by without adding support material, then your life is going to be happier. Quite often, I'll design parts intentionally for 3D printing and try to make sure that they don't use support material. If you do have to use support material on the Monoprice Mini, one of the things that I suggest is that you change your setting here from 0.1 millimeter up to 0.2 millimeter. And I find that really helps the support material break away more easily afterwards. It just gives you that extra little gap and that extra little bit of space that makes your life go easier. But again, to make your life easiest, design your part so you don't need support material. Now, what you see down here, these blue lines right here, are what are called a brim, and they're designed to help hold your part down onto the bed. If we do everything right and the print beds are nice and clean, on the Monoprice Mini, I haven't been needing to put any kind of build plate adhesion material down lately, and I've just been printing the object. But since we're here, let's take a look at a few of the different choices. You can use a skirt, which just runs a few lines around the outside to make sure the nozzle is clean and ready to go. It's really not doing much to help you with adhesion in any way, shape, or form, but does make sure that the nozzle's all ready to go and that you're dialed in and ready to print your part after the skirt has been printed. We saw what Brim was. The other one that's quite common is Raft. And let's slice the Raft in right there. Now, the Raft is a little bit different because where the Brim was just one layer and it was part of the bottom layer, the Raft is actually printed underneath the project, and it starts with widely spaced lines pressed hard into the bed and designed for maximum adhesion to the bed. And then it builds its own flat build surface right on here for your project to start printing on. And you'll see that it leaves a little bit of a gap right in there, just enough of a gap that it stays connected, but not so much of a gap that when your print is all done, you can't break it away in here, because you want to be able to snap this off and get this out of here, get rid of all the blue stuff. There's a whole bunch of different options that you can pull out on any of these settings. If you come in here and click on the gear logo, you'll see that there's so many different settings. So if you want to add any of those settings to your window so that you can work on them, you can just click on that setting right in there. The one I want to work on is the Raft extra margin. You can see that the Raft comes quite a ways out to the edge, and I find that tends to be a little bit of a waste of material to come 5 millimeters all the way out. You could set it to 3 millimeters and slice that. And I find that'll print just a little bit faster, use a little bit less material, and still have equally good adhesion. So once you've gone through and sliced your file, it's really important that you take time to take a preview of it. Okay, then you're good to go. What you can do is you can save to file, or if you've got a removable drive plugged into the system, you'll probably see it flash up and offer you the option to save directly to the external drive. Okay, there you go. It'll say save to removable drive, and then you can just take that and walk it to your 3D printer and plug it in. Personally, I'll save to file because I'm not going to a printer right now. Click on save to file and go ahead and put that into your 3D printer models folder, and notice the name on here, it modifies it. Okay, Maker Select Mini V2 with the E3D head. There's my file, and it's now got the G code extension on it, and it saves that file as G code. All right, so that's printing one of them. Well, what would you do if you wanted to print two of them? Okay, because that would be a far more efficient use of your print time. And come back here, take a look at your options over here. You can move. Try not to scale if you've got your size right the first time out, but you can definitely come in here and pick that up and move it around. Right click on it. You've got all of these options right in here. Multiply selected model. Give me 3 more copies. And if you want to print that many copies, you'll want to make sure that they're all aligned so that they fit on the board. So pick up, move, and move them around so that they've got space to all fit together on the bed. Now, I won't say that's all that there is to setting up a 3D print. But for an FDM printer and a small part with no particularly complex supports, that's a pretty good way to go about setting it up. All right, there's a little introduction on how to set something up in Cura.